This is a demonstration on how to simplify square roots that have variables. In my first example, I have the square root of x to the 6th power. I need to try to figure out what two things I can multiply to get x to the 6th. X to the 6th could be factored as x to the 1st times x to the 5th power. If we recall our rules with exponents, we actually add our exponents when we're multiplying variables together. X to the 6th could also come from x to the 4th times x squared. Also, x to the 6th can be factored as x to the 3rd times x to the 3rd. Since those two terms are identical, that's going to be my square root of x to the 6th power. In my second example, square root of y to the 4th should equal y squared, because y to the 2nd times y to the 2nd is equal to y to the 4th power. If you notice, there is a shortcut with these. If I just take my exponent, so my first example, my exponent was 6. If I divide that in half or divide by 2, that was my new exponent after I did the square root. So half of 6 was 3. Half of the number 4 is the number 2. When I get to my third example, 7 is not divisible by 2. So I need to factor this in another way. I'm going to factor this as the square root of n to the 6th times square root of n to the 1st. 6 plus 1 equals 7. I want to use n to the 6th because it's the largest even number just below the number 7. N to the 6th is a perfect square, and the square root of that is n to the 3rd. I would just take my 6 divided by 2, so my new exponent is 3. My other n to the 1st that's under the square root is not a perfect square, so it will remain under the square root symbol. In my next example, there's 4 variables I'm looking at. 3 of those variables have even exponents. That means I can do the square roots of each of those. So the square root of m to the 4th is m squared. The square root of n squared is just n to the 1st, or n. And the square root of p to the 6th is p to the 3rd. And basically what I'm doing is just taking those original exponents and dividing them by 2 or cutting them in half. Now I have an exponent that's an odd number. So I do need to factor this. And my largest even number just below 5 is a 4. So I'm going to factor this as w to the 4th power and w to the 1st power. W to the 4th is a perfect square. So I can do the square root of that, and that would just be my exponent of 4, cut it in half, so that means its square root is w to the 2nd. My other w to the 1st does not simplify, so that w just remains under the square root symbol. Our next example has a coefficient, so I'm going to start with the 140. And I want to try to factor this into something that has a perfect square as a factor. 140 is divisible by the number 4, so I'm going to break that down as square root of 4 times square root of 35. My square root of 4 does equal the whole number 2. My 35 doesn't simplify any further, so it will remain under the square root. Next, I'm going to go back and look at my variables. I have a to the 7th. That one is an odd number, so I need to factor that using the largest even number, just below 7, which would be 6. So I can factor that as square root of a to the 6th times square root of a. My a to the 6th, I can do the square root of that, and I'm just taking the number 6, cutting it in half, so that means the square root would be a cubed. My other letter a will remain under the square root symbol. It doesn't simplify. My next variable is b to the 10th. 10 is an even number. It is a perfect square. So that means I can just take the 10, cut it in half, and b to the 5th would be my new exponent. And then my last variable is an odd number, so I need to factor that down. 4 is the greatest even number, just below 5. I can do the square root of c to the 4th. That would become c to the 2nd power. My other single letter c will remain under the square root symbol. Next example. I have 3 even numbers, so I'm just going to emphasize what those are. So I can do the square roots of those ones. I'm just going to divide each of those exponents by 2. And now I'm going to take a look at d to the 15th. That's not an even number, but I could factor that as square root of d to the 14th times square root of d. Then I can divide that 14 in half to be d to the 7th. So now I'm going to write my answer, alphabetical order. And the square root of d doesn't simplify, so that's going to remain within my answer. Okay, my last example, square root of 12. If we recall, 4 divides into 12 and it's a perfect square, so I want to split this up as square root of 4 times square root of 3. Square root of 4 equals the number 2. However, I also have a coefficient of 5 that's out in front of my original square root, so I need to take 5 and multiply it to 2, which means 10 will be my coefficient in front of my simplified answer. The square root of 3 doesn't simplify, so 3 will remain under the square root. Next I'm going to look at my variable a. It has an even exponent, so that means I can just cut that exponent in half, so its square root becomes a to the 15th. My b is not an even number, so I'm going to break that into factors as b to the 16th. That's the largest even number, just below 17, times b to the 1st. b to the 16th, its square root becomes b to the 8th power. My other letter b has to stay under that square root symbol. And last I have c to the 40th. That is an even exponent, so its square root would just become c to the 20th power.